This is Polarized Light Microscopy in Archaeology, and we are now in Lecture 2.1, the second part of the course on Polarized Light Microscopy in Archaeology, which includes a number of example studies of the application of this technique. And the first of these is based in the Tigris-Euphrates Basin. So, most of my work on pottery has been based in the Middle East. You can see many of these are actually sites I have sampled. Even some of the sites not within the Middle East that I have sampled actually have pottery from the Middle East that went to these other parts of the world. And so it's mostly focused in this part of the world I've been working on. And you can see by looking at the key here that there's a lot of medieval sites or Islamic sites from which I've done a lot of work, from Yemen, all over the Middle East. But also there's all these little yellow sites, and these are all the ancient sites going from the Neolithic up until much later pottery from Bronze and Iron Ages in the Tigris-Euphrates Basin. And here's the Euphrates, and here's the Tigris. And so this is for a number of reasons. I've published papers from the Upper Euphrates at Tel Hadidi and Godin Tepe, where there is a major research project. But I've also Nippur. We have a lot of pottery from Nippur at the ROM. But it was mostly just a matter of having a look around to see what is the nature of the Tigris-Euphrates Basin, to try and create a general model for what the Tigris-Euphrates Basin looks like with regards to petrography of the pottery. So here is the geology of that part of the world, the entire Middle East. So you can see here the Tigris-Euphrates Basin. The basin as a whole would probably include the Gulf, the Persian or Arabian Gulf, depending which side of it you're on. And it's surrounded by the highlands of the Zagros and Taurus Mountains, and also of Arabia, which is not quite as high, but still quite significant. Now, how this terrain developed was due to plate tectonics, where you had the Eurasian plate and the Afro-Arabian plate colliding along this line. So these thrust zones, this is where the two plates slammed into each other, and the Afro-Arabian plate went underneath the Eurasian plate. So here you can see this is what this part of the world would have looked like at one stage, with the highlands here of the continental crust of Eurasia and the oceanic crust of the Afro-Arabian plate coming in. But then after a while, the continental crust of the Afro-Arabian plate came in, and they collided and got stuck. So this is what you have. So what typically happens in a situation like this, and you see the same in the Ganges, it creates actually a bit of a lowland here below the mountains. As this is being pushed up, this is being pushed down slightly. And so that's what this is here, is this valley just below the mountain range from the collision of these two plates. So the Afro-Arabian plate has a continental crust underneath it here, and this is a Precambrian shield underneath here. So it's a very stable platform, very flat lying rocks on top, you see. You can see they're flat because they cover large areas, you see. Whereas over here we have what must have been a whole bunch of smaller islands accreted onto this plate as it careened across the surface of the Earth, acquiring microcontinents and other archipelagos and things like that. So On this side, it's actually very complicated, whereas on this side, it's actually quite simple. Whereas in the middle, it's mostly just mud. And of course, the mud will come from up here. So this map shows again some of these sites. I actually named them now, which is nice. From the Tigris-Euphrates Basin, and this is a slightly geological map. This is all sedimentary rocks, but here it's all quite flat-lying ones, whereas here they're all turned into mountains. But up here you get felsic volcanic rocks. You have ophiolites. Ophiolites are basic, or in some cases ultra-basic rocks, which were formerly part of the oceanic crust. So this would have been part of the ocean between Arabia and Asia until they were slammed together and it all got rocked up and brought to the surface. So these ophiolites, as they're called, are very important archaeologically, because this is a source of a lot of raw materials. Metals in particular come from this sort of terrain. So we'll start off by looking at a site in the Upper Euphrates called Tel Hadidi. So here is Tel Hadidi, and this is Tel Swayhat here, which we have as one of the labs in this course. And here we were looking at Bronze Age pottery, and you can see this is an old photograph, so it's not as clear as it could be, but we have a big chunk of basalt here, and one thing you will get right away is that this is not a very well sorted population of grains. You have big bits like this, and you have lots of little bits, and there's quite a difference in grain size. So this would not be a well sorted sortedness going on here. There's quite a lot of diversity in the inclusions. There's various sorts of opaques. There's lithic inclusions, rock inclusions. There's a ferromagnesium mineral here, and this thing, which we'll get to, and what is probably quartz and feldspars, and all sorts of other stuff in here. So it's a bit of a catch-all for all of the Taurus Mountains, which would have been the source of the Euphrates here. Here is a nice pyroxene from probably a basaltic rock of some sort. Here are some felsic volcanics, or certainly intermediate volcanics. This is like a trachytic type of thing. These look like volcanic glass of some sort. And so it's kind of coincidence they're all on the same slide, but that works quite well. So things like this. And here we have something interesting. A couple of interesting things here is there's another volcanic here, and here's a basic volcanic with lots of magnetite stuck here between the plagioclase. And here's this red thing. And so red things tend to be things which weren't red before they were fired and then were turned red during the firing. And there's a number of things that do that. It's not always difficult to discern between them. But in this case, it's a classic example of seeing it and then trying to find something that looks like it, which is a bit more diagnostic. And this one is a lot more diagnostic. This is serpentine, the mineral serpentine, magnesium silicate, hydrous magnesium silicate. And this is from those ophiolite sequences I was telling you about. And this is from the alteration of a ultramafic olivine-rich rock. And the alteration of the olivine turns to serpentine, and the olivine, which is a magnesium iron silicate with no iron in it, turns into serpentine, which is magnesium silicate, and iron oxide. And so you can imagine this area is a very good source of iron, but also because of sulfates in the on the ocean bed, you have a lot of copper as well. So these metals are very important to humans, and so this sort of thing, in this case, isn't really related, but the relationship will come up a bit later on in this lecture. So serpentine, yes, we get serpentine coming down from the mountains. Also chert, see this is chert, again from Tel Hadidi, with little microfossils in it, very distinctive. So this has developed within limestone and weathered out and come down to the site. This is kind of angular. A lot of these are very angular. Angularity would be because it hasn't been worn down much, and that may be because it's been crushed and added deliberately, and there is a bit of that to it. Or it may just be that it's very close to its source, and there's a lot of variation in that sort of thing. There are slightly rounded things, subangular things, and angular things. So it may just be because this is a bit of a mix-up. And here's what looks like an amphibowl, judging by two cleavages. This definitely looks like it's been deliberately added. This is all calcite. Here you have angular inclusions of sparry calcite crystals, and here we have a micritic carbonate, and so this would be all added to this fabric, which if you took out the calcite, it would look actually very different from the usual Euphrates sediments of the other Tel Hadidi pottery. So it would suggest that this is a very specialized clay resource which has been selected because it works very well for something, which in this case is for cooking pottery. Cooking pots are actually very important in the ancient world, and it's a very demanding use to heat something up repeatedly. And so the good cooking pots would tend to be selected of particular raw materials. Possibly after their construction, they will be traded over a considerable distance. Another thing you'll find is they will be tempered sometimes with materials which work well with the reheating of the fabric, and calcite is very good for that. So we have a suitable clay and a suitable temper which has been added to work well with the clay during the repeated heating and cooling of a cooking pot. And because the problem with inclusions is if they do not expand and contract at the same rate as the clay, they blow your pot up. So you don't want that. So that's why adding calcite is a good idea. So back to this map, and now let's look at Nineveh, which you may think of as being this very important Neo-Assyrian site up here, but Neo-Assyrians. But I actually looked at Ninevite 5 painted pottery, which is quite old. And this is also a very old photograph, but you can see lumpy bits of calcite. So this is probably not from the Tigris. This is probably some sort of local limestone-rich deposit. But an important thing that we get a lot in the early ceramics is plant inclusions, plant fiber inclusions. And so you can see here, because this is fired under very reducing conditions, there are plant fibers left, which is a bit of a clue to tell you that this was a plant fiber. But it's possible under oxidizing conditions for this to completely vaporize and have nothing left but the void. And here are more of these plant fiber inclusions, and again with a lot of limestone in the matrix. So plant fibers need more work. Someone needs to do a lot of work on plant fibers. Traditionally in the literature you'll find people looking at plant fiber inclusions, which you can barely see without magnification, or maybe they got a magnifying glass out or something and said, oh, this looks like it has voids from plant fibers, and they'll often use the word chaff tempering. And chaff is a very good temper, and I think we do have evidence for chaff tempering, but this is not chaff, and neither was the thing in the previous slide. This is some sort of raggedy, long plant inclusion. We also get, and we do get chaff from wheat or something like that, and we get things that look like reeds, judging by the silica deposit left behind. And we also get things which are very raggedy. They look, frankly, they look digested. And so it's probably from not plant fiber tempering, but dung tempering. And so this has largely been through observation and hypothesis, and it really needs someone to do a lot of work on this, characterizing the different inclusions and hopefully reproducing them through experimental archaeology, which would require making pottery with plant fibers and dung and seeing what turns out. But I don't think I'm doing that, so I'd like somebody else to do that one day. And here is a very similar chert with those microfossils in. So that seems to be on both sides. I have to wonder if it's not coming from somewhere in between and not actually from the Taurus Mountains at all. Also, we get the very similar things of types of basalt and other inclusions. So the upper Tigris and the upper Euphrates are not very, very, very different because their sources are right next to each other. And here's some volcanic glass, you see, with the bubbles in it. So it's sort of like obsidian. So the next group of sites are in the Zagros Mountains. This is the Zagros Mountains. And this is from, partly based on the major ROM excavation at Godin Tepe and Segabi. Godin Tepe was this very important site excavated by the ROM in the 70s. Segabi is a nearby site also excavated because it had earlier material in it, but they didn't get in the sequence at Godin Tepe. So I've, and this is what it looked like in excavation. I've done quite a lot of pottery from Godin Tepe of many periods. This is Bronze Age pottery, which I thin section quite a lot of. And this is a typical fabric for a lot of that pottery. And it has a lot of inclusions of shale in it. So this is an argillaceous natural deposit from the deep ocean basin that existed between the two continents when this was being deposited. The usefulness of the shale is it has this facility, and so it's oriented quite often clearly in very specific directions. And so I thought I'd have a go at looking at the orientation of the grains. These types of pots are often break along here, so that would suggest the top half was made differently from the bottom half. And looking at grain orientation, and this is a thin section in the normal way, looking, so you normally cut a thin section at right angles to the side of the pot, like this. And this is the orientation of the grains within it. Whereas over here, this thin section was taken with a section parallel to the side of the pot. And so it shows a completely different orientation. And so you can see there's a major difference between the orientation from the top bits compared to the bottom bits in both orientation. And so you can actually relate this to two important types of construction at the time. This is slab construction. And so with a slab, you flatten the pottery with just by slapping it around, by rolling it or something. And this will create a lot of pressure. These are taken from a book on pottery technology by Owen S. Rye. So this is his illustrations here. And you can see that orientates these grains so that it's parallel to the surface from the pressure each side of the vessel wall, whereas in this direction it's completely random. So if we look here, this is quite parallel, whereas here this is almost completely random. And so that would suggest that this is slab construction, whereas this is from coil construction. And so if you imagine, coils are made up by rolling lots of coils and then slapping them on top of each other. And so that will orient the grains this way in the direction of the coils as they're applied. But if you look at a section through the coils, they'll be almost random. What they probably would be was a whole bunch of going around in circles, and then random bits where the circly bits were stuck together. And in fact, you do see areas which are more random and areas which are sort of all going around in circles. And so that would suggest the top part was using coil construction. So as I say, I did this on a couple of bots just to see what it's like, but it would be an interesting thing to do in a larger study if anyone ever wanted to do that one day. So apart from the shaly fabric, there are also a whole bunch with more metamorphosed rocks. And so there are a number of fabrics from Bronze Age Godin Tepe, and it's hard to determine which is the most dominant. Well, the shaly one was the most dominant, but there was quite a lot of the ones with metamorphic rocks, and also a granitic one with granitic rocks. And also you have this one. And this again is a cooking pot. And here you have this very large ferromagnesium mineral, and there's quite a lot of this in the fabric, suggesting this is a completely different clay from a completely different place. And this has been tempered with calcite, and again, this is a cooking pot. So this has probably been the result of quite long distance trade in cooking pots to get it here. So here, this is Godin Tepe here, and this is Segabi. This is actually an overlay in Google Earth. See, here's the scale, and here's Google Earth. And you can see that these are intrusions into the Zagros Mountains. This is the high Zagros up here. And these are sediment. These are the valleys where the Godin and Segabi are. And this river here, this stream, is the way that the sediments will be going. And so you can see there are metamorphic rocks, and there are sedimentary rocks. Of course, this is actually from a map of all of Iran, so it's not very detailed, but it shows the kind of terrain that these minerals would come from. So in the Chalcolithic period, Segabi was excavated because of its earlier pottery from the Chalcolithic period, and they also excavated some other sites for Chalcolithic pottery. These are from Segabi. I thin sectioned some of these to see what they were like, and these are very different. They're much earlier, and like the earlier pottery from Nineveh, there's a lot of plant fiber in it. So you really need to understand plant fiber to really get a grasp on what on earth these potters are up to. But one thing I did sort of get from the fabric diversity of this pottery is that it is very diverse, but also not very. It's sort of like if you look at the pottery made in the medieval period or the Iron Age or something like that, or the late Bronze Age, you get larger production centers making far more standardized products. Whereas these earlier pottery productions are probably more household related. And so each household would make its own pottery. And so the potter would go out and they would probably go to a specific place, because it's not like you can go and dig a hole anywhere. Different parts of the area around the village would be the responsibility of different households. And so you would go to your place, your own fields, or your favorite bit of the river that you go to get your pottery, and you probably wouldn't go to where other people go, because then you'd be interfering with their access to raw materials, which probably would make you very unpopular. And so they're sort of similar insofar as they're all made in the same place at about the same time, but they're dissimilar in the fact that they just do not seem to have the standardization you would have in later periods. And I also see this in the Neolithic, like at the sites from Jordan, which I've looked at. It seems to be more diversity in like a single household, not that you can rely on it being a single household, it's just from about the same area, than you would from an entire city worth of production in the medieval period. So another fun thing from this part of the world is from the 3rd millennium BC, from Godin Tepe, and also Sangalan Tepe, which is a bit over here. It's on the other side of the high ridge of the Zagros. And it refers to pottery like this. Again, it's an old photograph, which I kind of like, because someone filled it, I believe, with flour to make it look more obvious. These are actually, should be lime filled, and they don't look quite as obvious now, and a lot of the lime has fallen in. So when these people took this photograph, they just put a lot of flour in there to sort of show up the white bits, which I thought was kind of fun. Probably wouldn't do that nowadays. So what's fun about these is they all have grog in them. So these, this here, as I'm outlining it, this is an inclusion of grog. A grog to archaeologists is pottery. So this is pottery which has been ground down and added as temper to the pottery. Yeah, and so this is a fragment of pottery which has been broken down and added. And if you look in this, here is another piece inside it. So this is a piece of pottery which has been broken down and put in a piece of pottery, which has then been broken down and put into another piece of pottery, which actually seem to happen quite a lot with these so-called Transcaucasian wares, these black and white pots. This is from Sangalan Tepe, which has the added benefit of having some very nice tourmaline in it, which I quite like. I think it's one of my favorite minerals in thin section. Here's a very nice, here's another one. Nice euhedral one there, quite like that. But here there's a lot of grog. And so it seemed to be a thing that wherever this Transcaucasian ware was, they would be doing a lot of this grog tempering. And although there weren't a lot of samples, I rather got the impression that looking at like a couple of the ones, particularly from Sangalan, that, for instance, this one, this is the grog, you see, on this side, and this is very different from this. And, you know, I did a bunch of pots from Sangalan. I think I got an idea of what a local fabric would look like. And this isn't it. And this isn't it either. So that would suggest that this piece of pottery here was made at a different site. Then it was taken to this site where this piece of pottery was crushed and added to this pottery. And then this whole piece of pottery was taken to Sangalan Tepe where it wasn't made. And so this would suggest this is a very mobile population. Now, while you add temper, this is my while you add temper slide, this has temper in it. See, lots of little things added to it, often called aplastic inclusions, although I guess plant fiber is not aplastic, and certainly dung isn't. But what temper does is it does a number of things. One is it makes the clay more workable while you're trying to turn it into a vessel or whatever it is you're trying to turn it into. When it dries, it will reduce the shrinkage. That's particularly important in this case. I stole this from somewhere. I don't know where it's from. It could be from a book or something. But this is, you know, it's the same vessel, but the tempering is very different because this has a lot more temper in it because it's a handle. And so probably what they were doing is they were making the pottery vessels and letting them dry and then adding the handles as some sort of mass production effort. And so this, they wanted to not shrink as much as it would if it was just a pottery vessel, because if it shrank too much, it would fall off. You can see it's starting to crack here anyway. So reducing shrinkage during drying is also important. So during the firing itself, temper will provide desirable properties for that. And also it would provide desirable properties to the finished vessel. So plant fiber is very good. It's particularly very good for aiding workability, especially dung. It makes it very workable if it's like not very workable. And of course, plant fiber burns away, and so it doesn't cause any problems later on. Calcite is very good for the finished vessel if it's a cooking pot, because it will expand and contract at the same rate as the ceramic body. Grog is useful in that it doesn't have any impact on any of these things at all. If you want to add it to the clay because it has too much clay, it's too fat it's called, and needs some aplastics in it, you can add almost as much as you like, because it's just more pottery and it will all fuse together in the end. So you can add wherever you go. If you want to temper your pottery, you can easily break up a pot and add it to the paste. And so it seems like grog is a good idea if you're a mobile population, because you don't have to experiment with it. You don't have to wonder, how is this going to work in the firing? It's pottery. It's going to work in pottery. It's just normal. So again, that seemed to indicate a mobile population, possibly. And this whole group is actually associated with mobility. I started up here, often called the Kara-Araxes culture because it's from the Kura and Araxes. And it's also from Transcaucasia, being on this side of the Caucasus, from the other side. But they moved around a lot, you see. And all these areas you get this kind of pottery, including Godin Tepe down here. And they're actually associated with being very mobile. In fact, they're associated with moving around on chariots, which I kind of like. Anyway, so that's a hypothesis. So, yes, chariot driving pottery makers. So, next we have a site down here, Ur, which is one of the best sites in the Middle East, only 2 letters in its name. Ur is down here, and you see the big basin of the Tigris-Euphrates. This would probably fill with water a lot of the time, and in fact, the time that Ur was occupied, the sea probably came all the way in this way. So here is Ur. Here is Al-Ubaid. And here is Ubaid pottery, which I didn't thin section, but it gives you an idea. Anyway, so this is pottery from Ur, and this gives you an idea of what this part of the world would look like. And it's not very interesting if you like exciting inclusions. It tends to be quite well-rounded, well, not well-rounded, rounded, let's say rounded. And so there's a lot of quartz and feldspar, and generally quite dull, and quite well sorted. And so this is a very mature sediment. This one looks exactly the same, but it's from Bahrain, and it's of pottery of the same type, which was thought to possibly be from southern Iraq, and it looks like it is. This is a slightly nicer photograph. We've got a plain polarized light, across polarized light, so you can see it's got some plagioclase and quartz and a bit of chert and that sort of thing. But as you can see, it's basically the same fabric, rounded, or at least sub-rounded, and quite well sorted. So that piece of pottery, the other piece of pottery come from here, but that last piece of pottery came from Bahrain, which is a very important site in the connection to the copper production area of Oman. And if you remember, Oman has that thrust line going through here. And so Oman has a lot of ophiolites, those fragments of oceanic crust thrust up onto the Earth's surface during the collision of the 2 continents. And of course, the ophiolites are associated with tremendous resources, one of which is copper. And one of the largest resources for copper in the ancient world was Oman. There are smaller ones, of course, all the way along the Zagros thrust zone, but this was a massive one. The other massive one, of course, is over here in Cyprus, which is actually named after the fact that copper came from there, because it's Cyprus, you see. But during this period, they were getting copper from Oman. And so it's thought that there was a lot of trade going on. So some of the pottery from Bahrain was probably local. You know, it's very silty and like it's in the middle of nowhere, and there's not a lot of interesting stuff getting to it from anywhere. And so it's probably a local fabric. It's the most common one, and it looks like local pottery. And this has a bone in it, which I thought you'd like. And but then there was this pottery. And you can see that this looks familiar to you if you were paying attention where I was talking about some of the other sites. I don't believe that. Some of the other sites, which were have serpentine in it. And if you remember, serpentine comes from ophiolites. So this pottery probably comes from Oman, and it's going to be a part of that trade network for copper, but they brought pottery along as well. So, looking at that pottery, the Ubaid pottery and the pottery from Ur, I mentioned how it was from a mature sediment. And looking at the pottery from Tel Hadidi, I mentioned how it was poorly sorted, very diverse, a lot of angular fragments. That would be called an immature sediment. And that, from looking at all of this pottery, seems to be what we see going on here. It is possible, by looking at the pottery, to say, yes, this is the Euphrates, but this is more mature, so it's from further down here, as opposed to the less mature production centers up here. And the same goes for the Tigris. And so it is possible to make general models that will give you an idea, is the pottery from down here, or somewhere further up. And the relevance of that will actually come up in the next lecture. So that's it. Thank you very much.